by Marco, and it's titled Initial Step in Integrating Large Reasoning and Natural Model into this composition.
Thank you. So just as a disclaimer, this is going to be a lot of hand waving. At the beginning, general hand waving, and then more specific hand waving. So it's a hand waving talk. There's not much technical content. And about the general hand waving, I think we all agree that AI is eating the world. I think all the talk, if not most of the talk, were about AI in this, right? Some AI-related content. This one will be no different. It will be in that line. And if you look at about from an economic point of view, these companies, you could say, oh, AI-related, and they have huge capitalizations. I'm doing this just to put OpenAI there, which is not traded, but it's considered to be worth 300 billions. And speaking about OpenAI, there was this recent news. How many have seen this announcement? Few people have seen it, right? So what happened is that OpenAI has bought the company of John Ivey, I don't even remember the name, who was been product designer and industrial designer for Apple for over 20 years, and he had gathered a bunch of very good engineers and built a company, and actually was acquired for $6.5 billion. And the best comment I've seen online about this was when some user on an online, on a social media forum that actually said, company with no business plan buys company with no product for $6.5 billion. Now, the good news is it's a stock deal. So the $6.5 million are nothing. It's just paper. It's not real money. Okay? But it tells you a little bit, it reminds me of the internet bubble of 25 years ago. This is where we are, I think. Another nice example is this one, Builder AI. How many know what happened here? A couple of people know? Yeah, so it was Builder AI. It was a great company, valued at, I think, 1.5 billion, so a unicorn. And they were building software to build software. So they were saying, you can make software as easy as ordering a pizza. Because we have these great tools that we're selling. They got a huge amount of money from Microsoft and some venture capitalists, actually almost $500 million, 450 million. Turns out, it was 700 Indians programming, and the amount of AI was actually very limited, right? Oh, sorry, I should have gone ahead here. And so they managed to burn 450 million, and in addition, another 100 million of cloud fees that they never paid. The only good news I can see in this, that actually were very sustainable. So if you look at the average energy consumption in India, in one day, 700 people consume about 2 megawatts, which is way less than any AI model that you can think of, right? So yeah, but sustainable. So actually, it's a pity they bankrupted. Good, and last year I think I showed this figure, which I have updated, and saying, well, there's about 10,000 papers in the last 12 months in archive that have the word LLM and ChatGPT inside of it. So this year I just updated the figure, and I can tell you it went up. So we're at almost 18,000 papers. This is all disciplines, not only computer science. Clearly computer science has the biggest share. And you can see the growth, which is really, really fast in the last year. So it's really, really growing a lot, and have to admit, guilty too, like everybody else. So yeah, we wrote a lot of papers ourselves, or some by myself in this area. Mostly we are looking at services and service composition as the main topic. But yeah, we're polluting like anybody else, let's see. So now I go to the specific hand waving. It's about service composition, which is a topic we've been working for over 20 years. Just to make sure we're on the same line, what is service composition? You could define as the process of integrating independent, loosely coupled services, starting from a user request based on the ones available in the execution context of the moment. And the service must be able to communicate with each other, are modular, flexible, and you can do dynamic compositions. So things can be decided at the last minute, and you have an extra component called the orchestrator, which is the one who's responsible for their execution. Kind of the classic, if not the central, problem in service-oriented computing. And since about 25 years, maybe 22, we've been advocating to use AI planning. So for those who are not familiar with AI planning, what is AI planning? It's a discipline of AI, traditional AI, if I may say so. And typically you talk about a goal, a plan, and an environment. The goal is a state, a desirable state that you would like to be in. The plan is the set of actions in a certain order that will bring you to that state. And the environment is something that describes the way in which the world works. And so something that tells, given this action, you can expect this reaction of the world, or these reactions. And it defines all the possible things that can happen. And the mapping with service composition, for us, it looks quite natural. The goal is the user request, so whatever it is that you want to achieve. The plan is the composition that has to be orchestrated, and the world is the set of operations that the services interface, plus potential additional environmental factors. These days, Open API is a popular way of describing those actions that you can take. But there's also a lot of physicality, so sometimes you need to put also some domain knowledge about how the physical world works. So the title of the talk is the role of large reasoning models and action models. Just to say what these are, so they're all deep neural networks. Large reasoning models are typically trained on codes, on formal data in addition to natural language processing, and the expected ability is one of reasoning. So things that through long chain of prompting can come with a description of a reasoning task, of a plan, of a set of actions that you can take to achieve some goals. And often you use them in combination with other systems like RAGs are also very popular, or other forms of theorem proving sometimes there. So you can augment their abilities to make them even more precise, hopefully. Right? So they're good for automated theorem proving, scientific discovery, decision support, to some extent for planning. Now we submitted this paper to SummerSOC. What was the deadline? February? Yes. And of course, just 1 week ago, someone writes this paper. There's delusion of thinking from the guys at Apple, and Benja's one of them, saying, this stuff don't work. Right? Anybody has read this paper? Okay, then I would like to have a conversation with you guys to know what you think. Right? But basically they say, so on small problems everything works fine, be happy. But as soon as the scale of the problem grows, then these things can't handle it anymore. Some people, even though it's super recent, this paper, I really think it's 1 week ago, 10 days ago, some people say, okay, this is the end of it, LRMs are doomed, no chance. Others say, well, yes, some things we knew, but there's still some space for improvement and still some things that can still be done. And just to make things work, another person very active in this field, which is Patti from Arizona State University, also says, stop anthropomorphizing these systems, these models. Intermediate tokens in a chain of thought don't actually represent human reason. So these intermediate tokens might have some statistical validity, but it's not the way in which people reason. So a lot of controversy over this model. I have to say, for some of the experiments that we run on service composition using OpenAPI specification, I have to see there is some level of success. Right? So they are able to do some tasks. And this is why we are exploring further this field. Especially in the discovery part of the service composition, I think we find pretty reasonable success rates. Second technology, if you want to say, is the large action models. So these are kind of the opposite of the large reasoning models. Instead of being something about how do you go and make your chain of thoughts, it's really trying to translate some set of inputs into an action, something that you can actually send to a system, to an OpenAPI, or also to a robot to do an action. So you take multimodal input, you process it, and you try to say, okay, what does this, to which action does this correspond to? It's not good for long chain of promptings, it's not good for reasoning, but it can give you good input for things like embodied agents, robotic manipulation, navigation, game environments. So the ability of these models is going towards the orchestration part of service composition. Right? So this is why we thought, okay, this might be the right answer for the orchestration and monitoring part of the service composition pipeline. So if you put them next to each other, as I said, they're kind of siblings of the same family. The large language models are known to be very good in natural language. They're good for translation, question answering, summarizing. They do tend to hallucinate, and they're medium good for some form of reasoning. I mean, we've seen emergent behavior in the form of being able to do basic math, right? So they do have some sort of that. Large reasoning models are also good at natural language understanding, and they're particularly strong at problem solving. Like also this kind of things like involving a form of knowledge of reasoning about reasoning. And so they can solve some of those tasks. But we also know it doesn't always work. There's tons of examples also in the planning domain where the plans are not implementable, realistic, or they make very basic spatial mistakes in trying to find path in a labyrinth or things like that. And then finally we have the action models that are good with multimodal input and in giving out handlers to objects or to APIs that you can interact with. So this brings us to this initial steps, this initial idea that Ilche and I were discussing to say, okay, so if you take the full pipeline of service composition, you have an initial phase in which you have to interpret the specification of the user, and then you have to identify services that can realize that request. And once you have that, then you can do the actual composition, which in this area, it's still kind of abstract. It's still not bound to specific services. And that part comes actually as the last one, in which you do the service with the execution, so the binding part, the execution part, and also possibly monitoring and fault tolerance. So the idea that we have in mind is the mapping of all kind of large models for the first part. So LLMs for the very beginning, and then LRMs for the second part. LRMs are the service composition engine. Here we have quite some results already. As I said, working with open APIs, with large description of services from Spotify and another one which I don't remember right now. But there we have experimented quite a bit and have some results on how that would work. And then finally, I think this is what is mostly missing from our work, but I think also from that of other people working on this topic, the execution side, the orchestration side. Good. So my hand waving is almost finished, and what I wanted to conclude with is telling you, we do think that LLM and LRMs and LAMs are relevant for service composition. Clearly, there's a lot of issues which are known and have been coming out as these tools are being developed. And I'm sure there's more that we will find out as we're working on that. And so there's a lot of uncertainty still. What is the real potential? How reliable they are? What is the level of hallucination that you will have and you can tolerate? So there's a lot of issues that we don't know yet. But there is still some promise, I believe so. And I hope to see you all next year in the same place, and hopefully with a little less of hand waving and a little more results. And
Okay.